Hello, this is just a quick demo of the GC-M9 controller, which is a dual 6,000 watt controller for a total of 12,000 watts if connected to a 50 amp circuit. I have it connected to a 30 amp 240 volt circuit, so I have to use a smaller element in order not to trip the circuit breaker. So essentially with this controller, there's a temperature controller, thermostat, which allows us to control based on temperature set point. At any point, the power to each element can be controlled using these potentiometers. Heat 1 refers to the heating element connected to this circuit. Heat 2, controlled by this. And if we follow their individual connectors, which are marked accordingly. Okay, so before we turn the power on, we want to make sure that both potentiometers are turned all the way to 0. That way, there's just less stress on the main power switch, which can handle up to 30 amp, but to extend the life of the switch, you want to minimize the amount of current that's being switched when you flip it on and off. So this switch basically allows us to change from temperature control, which is M for mash. This was designed with homebrewers in mind. So M would be temperature control, B would be power control. So we bypass the temperature controller and control each element individually with their respective potentiometers. Anyways, let's turn this on, see what it looks like. Okay, full power on. The set point is the lower value. The process temperature is the upper red value. The probe is connected using a simple stereotype connector, which simply pulls out. It pulls out. You can see the controller's not happy. It's telling us that it's not getting okay. Plug it back in. Takes a few seconds for it to start reading again. Alright, the temperature upper in this case is just a simple immersion type, which we have hanging in the air just for the sake of this demonstration. Normally you would submerge it in whatever you're trying to control. I also sell MPT type probes, which I will demonstrate in a different video. So how does this operate? Well, in temperature control, we can control the two heating elements as one, which would be tandem mode. So in tandem mode, when we are controlling by temperature, which would be mash, and as soon as I flip it to M, you'll see the power increase because, well, I would have to turn up the potentiometers, right, to feed some power to the heating elements. So as soon as we turn it to M, since the set point is higher than our process temperature, the controller will engage both heating elements to try to increase the process temperature to reach the set point. Alright, so let's increase the potentiometers just a little bit. Okay, we flip this on and immediately we see current increase. This is an average value reading watt meter / current meter, so it takes a few seconds for it to stabilize. Okay, I do have a 30 amp circuit, so I can crank it. On this circuit, I have a 5500 watt heating element. On this circuit, I have a 1300 watt immersion type. So if we crank it all the way up, we'll see the wattage increase. Okay. And so if we're in temperature mode and this tandem split switch, which essentially controls how this is connected to the temperature controller, how the heat number 2 circuit is connected. In tandem, the temperature controller is controlling both heating elements as one. Okay. Now if I flip this to in between, it essentially turns off this circuit. And you can see the power go down because we have no power going to heat number 2 circuit. And if I hit it split, it will essentially allow me to control this independent of the temperature controller. So, for example, on a 2-vessel system or a 3-vessel system, you might use heat 1 circuit to control your hot liquor tank based on temperature, and with heat 2 circuit, you would control power going to your boil kettle. So in this case, you can see that the temperature controller is trying to regulate the temperature, or trying to regulate the heating to reach the set point. So heat number 1 will always be connected through this switch right here. So I'm either operating in temperature mode M or boil, in which case I bypass the temperature control. Anyways, let's see what happens. So right now, if this switch is in between, my heat 2 is turned off. Now if I flip it to split, you can see the power go back up, right? Because I basically turned this controller, but just turned the heat 2 back on. However, now I'm bypassing the temperature control. So if I turn this down, I'm controlling this independent of the temperature controller, or this switch for that matter. So if I flip this to off, my heat 1 will turn off, but my heat 2 will stay on. As you can see, the power is still going through it. But my heat 1 is turned all the way up, and there is no power coming out of heat 1 because this switch, which always controls heat 1, is in the off position, or in between. Now if I flip it to boil, I will be able to control power going to heat 1 regardless of what the temperature controller is doing. So flip it back to mode. Now my heat 1 turns on because my controller is telling you to do so. But now I'm operating heat 1 in temperature mode. Heat 2 is split, so it's independent, so I can turn it up and down, and I don't care what heat 1 is doing, right? You can see what's going on here. But let's see, we got this turned all the way up because we're trying to have a really strong boil, whatever, rolling boil, or get the kettle, boil kettle up to temperature, to boil temperature, right? Now our HLT controller, hot liquor tank, is heating the water in the HLT, right? And let's say, okay, we bring the probe, we're heating the water, and the water in a few seconds will reach the set point. We'll see heat 1 turn off, okay? The LED went off. We can see the power go way down by about 5,500 watts because that's the heating element connected to this circuit, okay? But this guy is still going because it doesn't care. In split mode, this guy doesn't care what the temperature circuit is doing, what H1 is doing, heat 1 is doing, excuse me. So let's say we get it up to the point that we want the boil to continue, and we can turn it down however we want. The heat 1 circuit will just keep doing what it needs to be doing in order to maintain the process temperature. So we'll see once this drops to below the set point, we'll see the power go back up again because heat 1 circuit will turn on, will toggle back on. Okay, and let's say we want to continue heating the HLT, which we'll turn on in just a second, but we're done boiling, we're done with our boil. We can simply switch it to off position, and you can see the power go to 0, despite of what this position is. Okay, but I'll turn it down anyway, so let's say we're done. And we'll see the power go back, increase in just a few seconds once the set point. Yep, there we go. Power is going back on, or going back up because the controller is in M mode, is controlling heat 1, but not heat 2 because we're in between, which is off position for this guy. So even if I was to increase it all the way up, you can see there's no change in power. Okay, turn it down. Okay. So, yeah, that's it in a nutshell. And then you have additional 2 pump circuits, which can be used to power 120, 2 120 accessories. Pump 1 controls this guy. Pump 2 controls this guy. Each one is fused individually. with a 4 amp fuse. So if you try to power anything over 4 amp, you will burn that fuse and we'll have to replace it. Okay, so I can quickly demo what that looks like. Let's see, I got a fan here that I can connect to either... Sorry for the video work, I'm not a professional videographer, so that's why it's a little jittery. Okay, we're going to connect it to heat 1. Oh, there we go. Try and do this with only 2 hands. So here, if I turn this on, it lights up and the fan is running, as we can see right there. And if I flip it off, the fan will stop. That's winding down, winding down, winding down. There we go, it stopped. Okay, and you can see the switch is off. Same thing for this guy. We change it to pump 2 circuit. Switch it on. Fan is running. Okay, turn it off. Well, it takes a while for it to wind down, but you get the picture. So, anyways, this is a GC-M9 controller, which is can be used for really any kind of temperature process control, either in distilling or home brewing on a 2 or 3 vessel system. It can handle, once again, up to 6,000 watts of power on each circuit, so for a total of 12,000 watts. And you can control both elements as one when it's in tandem mode, or individually if split. Okay, and you can either control heat output by heat 1 and heat 2 in temperature mode, or in power control, which is boil, switch to that mode. So there we go. We can see the power go up accordingly. And then we can individually, if in tandem mode, this is split. So let's see, this won't control anything. We have to put it in tandem, either tandem, okay, in order to adjust power, or split. Okay. So if this is in tandem, but this is set on boil, I can still control the power going to heat element or heat 2 element. Okay. Off. You can see power go down. We turn this all the way down. Highly recommended before you flip the power off. No arcing in the switch, you'll extend the life. Alright, thanks. That's about it. And if you have any questions, feel free to reach out. Cheers.